Now open your MATLAB. After opening MATLAB, click on Simulink. Now open library to take the elements. So here you can take the elements what we required. First of all, take solar panel. In Simscape, SimPower Systems, Specialized Technologies, Renewables, you can get the PV array. So we add this block. And what we need to give a irradiation and temperature, right? So take the constant to give the irradiation and temperature values. And also take the scope. It is useful for the observe waveforms. In elements, take the RLC branch for capacitor and inductors. And go to power electronics and take a diode and IGBT with diode switch. And universal bridge also for designing the inverter and boost converter. And we also take a pulse generators, right? So go to pulse and signal generator. So here you can get the PWM generator to give the pulses to inverter. So for boost converter, you can take the pulse generator. So in sources, you can get the pulse generator. So now take the voltage measurement for measuring the voltage. In measurements, you can get the voltage measurement to measure the voltage. And last but not least, take the power GUI, graphical user interface. Without this one, we can't run the circuit. Okay. Now take all the elements and design the circuit as per our circuit diagram. So first of all, what we need a solar panel, right? So take the solar panel here and give it to the irradiation and temperature values, right? Take constant and give it to this one, and take the constant and give it to this one. Here IR means, here this is IR, right? Means irradiation. Here T means temperature. So take the irradiation like 1500, and here I am taking the temperature like 25, and give it to the one capacitor, right? So take the RLC branch and control R command to rotate this one, and take the capacitor C and give it the value is like nothing but 0.006 farads. Okay, and give it to the solar panel, positive and negative. To decrease the ripple factor, we are taking the capacitor here, because this capacitor does not allow the sudden changes. To protect the remaining circuit, we are taking the capacitor. Okay, so and then what we need here, after the capacitor, we need to connect a boost converter, right? So this is the boost converter diagram looks like. Inductor, diode and switch. Okay, so take the inductor, right click and drag and rotate this one. Take the inductor and give this inductor value is nothing but 0.02 Henry. And after that, connect the diode and connect the switch here for designing the boost converter, and connect the another capacitor here. So these four makes the boost converter, and give value is same 0.006. And now after boost up the voltage, our home required the AC voltage, right? So that's why I'm taking the inverter here. This universal bridge can make the inverter. So here input is A, B, C means this is the three-phase AC. So this plus and minus indicates the DC terminals. Here DC as the input and AC as the output. So means we need to flip this block, because this DC wants this side and this AC wants that side. Okay. So right click and rotate and flip block. And you can also use the command control I to flip this one. That's it. And take the two bridge, because we are taking only single phase. Click on this one and take the two bridge arms, because we are taking only single phase. And also take the switches like IGBT. Okay, now connect these two. And finally connect this to AC load. I am taking the resistance load and give it here. That's it. Here you can get the AC output. And to give the pulses of this inverter, take the PWM generator to level and click on this one and use internal generation only, and take here 0.8 pulse width modulation. And here our bridge is only single phase, right? That's why take the single phase full bridge 4 pulses. Click on OK and give it to this gate pulses. So now to measure the output voltage, take the voltage measurement, connect parallel to load, because how we are connecting voltmeter in our laboratory, same like that you can also connect voltage measurement here, and give it to the scope to see the waveforms. Give this pulse generation to this switch also. This IGBT with MOSFET also a bidirectional switch, right? This switch also needs a pulse generation to turn on, to turn off. Okay. So now give this and double click on pulse generator. Here take the time as 1 by 1500. Why? Because here they are mentioning the time in seconds, but we know the switching frequency only. So here I am taking the 1500 Hz frequency, means time is equal to 1 by f, right? That's why I am taking the T is equal to 1 by f. 1 by f means this 1500. Okay. And I am taking the pulse width modulation as 50%. And you can also take the voltage measurement here also to measure the solar panel output voltage, what we are getting before boosting, and take the scope here to see the waveforms. And you can also take the voltage measurement after boost up. Double click on PV array. So here these are the parameters we are taking for our project. So here I am taking the parallel strings 20 and series connected modules 5, and I am taking the 60 cells per module here. Okay, and our open circuit voltage is 36.3 and short circuit current is 7.84. These are the parameters I am taking here, and click on OK. Now run your circuit. After running, click on this first scope to see the output of the solar panel. Here you are getting the 120 volts DC, right? So in solar panel we are getting the 120 volts DC, but our home requires 240 volts, right? So that's why I'm connecting the boost converter here. So after boost operation, what we are getting, click on the scope, and here after boost operation you are getting the 240 volts, right? So here you are getting the 240 volts DC supply. Okay, in output of the solar panel we are getting only 110 to 120, but after boost operation we are getting the 240 volts, right? And now we give it to the inverter, and at the output of the inverter you are getting the alternate current. Zoom this one. So this is the alternating current, right? Here also we are getting the 240 volts AC, right? So this is the alternating current, but here we are not connected the passive filter. That's why we are not getting the pure AC, right? We only getting the pulsating AC, like square waveform. Okay. For getting the pure AC, we need to connect the passive filter. So connect the passive filter here to get the pure AC. So take the inductor and connect here, and take the capacitor. So here I'm taking the only LC filter. That's why I'm taking the inductor and capacitor and connect these two like this. That's it. This is the passive filter connection. Now run your circuit. So after running, click on this scope. So here you're getting the pure AC. That's the use of passive filter. Okay. Without connecting this filter, we are not getting the pure AC. But after connecting the filter, you can get the pure AC. So this AC we require for our home. That's it. This is the design of solar powered home. And in another video, I'm also explaining